Hi everyone, in this video I'm going to solve Leetcode problems. It is not going to be a first take since I've already solved that specific problem. I'm just going to try to walk you through and think together about the reasoning behind each problem. We have Leetcode 706 design Hashmap. So this problem is considered an easy problem, but we are going to implement the most, let's say, difficult solution, but at the same time it is the most efficient in terms of time and space complexity. So it says design a hash map without using any built-in hash table libraries. So we have to implement our own hash map. A hash map, since I'll be using Python, is basically a dictionary. So we have the three main methods that we have to implement, which is put, get, and remove. So basically what I'm going to do is initialize our hash map to about 1000. We're going to initialize it to 1000, which is, of course, they can expand, but for our implementation I'm going to use this value. And we are going to use arrays which basically, as you know, arrays have an index and they have a value. And in this case what I'm going to do is use the arrays, but then basically instead of the index we're going to have a key. And as you may know, a dictionary or a hash map is formed by a key and a value. Okay, so that's what I'm going to do. I'm going to implement arrays basically to create our hash map implementation. That said, the main problem is assigning a value to the key. And to assign a value to the key, we're going to use the modulo operation. You might be familiar with modulo. Is basically this operation. So for whatever number between 0 and 1000 we're gonna use modulo, and we are always gonna get the same value once we mod it, if that makes sense. So in order to get a single value each time, I'm going to use this modulo operation. We will also need a linked list, which is going to be defined at the beginning of our code, and this is going to be the approach. I will, as described in the description, I will implement the put first, the put method, then the get, and then of course the remove. For the remove part, I will simply modify the linked list. And as you may know, a linked list is basically a node that points to another node that points to another node. Okay, and if we have to remove one of these nodes, let's say that we have another one here and so on. If you have to remove one of these nodes, you can simply make the pointer point to the next node in order to remove that specific node, for example. So you don't actually remove it, but you simply make the pointer point to another node. So that's what we're going to do for the remove method. So here's the code, and I've already added the class of the list node, which is basically our node, and the attributes are key, value, and this is the pointer. So this is the pointer that we mentioned previously. Each node has a pointer that points to the next node. So that's the implementation of a node. So here we have our init dunder method, and we are going to initialize the list node basically. So I'm gonna use I'm gonna call it self.map, and for and I'm going to create a node like this. So this is basically a list comprehension, easier to understand once you familiarize with this type of syntax. So I'm just gonna write it here as a comment, comprehension, and I called it map. You could have called it whatever, array. This is a throwaway index, and that's how we initialize it to 1000, as we mentioned. One improvement that we can do is maybe add a self.size attribute, and here we can write the attribute, and here we just add size. That would have been maybe much easier. So next we need a helper function, which is the hashing functionality that we described, that basically uses the modulo operator. So we're gonna implement it and then reuse it in the next methods. And we're gonna have the key as argument. So we're gonna return key modulo self.size, and we can add type hints. Key is gonna be an integer, and the return value again is going to be an integer. Okay, so we're going to reuse that. So in our put method, I'm going to create a variable that it's basically cur, that stands for current if you want, and we're going to self.map and self.hash, because we are going to use the helper function that we created. And I add a comment for that, and we're gonna add the key value that is passed from the arguments. So that's how we create that hash value. We're going to use a while loop. So while we have cur.next, so while we have a next node, what we're going to do, if the key of that node, so if cur.next.key equals the key, I said equals, but that's what I meant, it double equal sign. If cur.next key equals key, then we update the value of cur of that specific node. So we cur that next that value equals to value, and in that case we return. So if not, we simply cur that next. So we keep going with this line. And if we keep going and we don't find anything, it's just gonna be cur that next equal listed node. So I'm gonna call the implementation of a node, and we're gonna pass the key and the value, and that's basically our put method. For the get method, we're gonna do the same thing. So we have to hash and use our hash helper function, but we're gonna skip the dummy node. So I will have to add that next at the end of this line, and we again follow the same procedure. While cur, if cur that key equals key, then cur that value we updated equals value. If not, we keep going to cur that next. Let's assume there is no value to get. Since this is a get method, we return -1, which is nothing. The value was not found. Actually, there is an error. We have to return in this case. So if the key equals the key that we pass as an argument, we return the value. So we return cur that value, and that's it. For our remove function, for our remove method, we going to hash again, and while cur that next, we have to check if the key is the same. So if cur that next dot key equals the key, we modify the pointer as we mentioned in our explanation. So we are going to cur that next equal the next node. So we're gonna skip one, and we're gonna adapt that pointer to the next node. So let's say that it's not found. We're just going to cur that next. So we're just gonna keep moving until we find it. Okay, so at the end here we have to return, and that should be it. Let's see if it runs, and let's see which error we have, if we have them. Okay. Set that size. So we don't have an error in the code, but we get a different output. So you might have noticed that we get a null in the output that corresponds with the put method. So the line 23, this should be next at val that equals value. Okay, so the answer was accepted, Let's submit. And that was it. This is Leetcode number 706.